Okay, so you can see some questions here, whether this first one here in particular has got fractions on both sides of the question, and it's asking me to find what x is. You can see x is on both sides, and if you've been doing stuff with x on both sides, you know there's a few steps that are required. This is going to add another step, but you're really just building on past successes. So as long as you know and understand everything that comes up to this point, it's really not much of a big deal. Let's have a look. We've got x plus 6 over 2 equals x over 3. Now, if I was trying to add together, say, a half and a third, what would I do? I would have to give them the same denominator, wouldn't I? I'd have to make them both into sixes. A half would be 3 sixes, a third would be 2 sixths, and I'd have 5 sixths. Okay? It's a similar thing here. I'm going to end up with sixths on the bottom. If I can do that, that means I can ignore them, and I'll show you why in a moment. But let's just look at the process we're doing here. What I'm going to do is I'm going to essentially cross-multiply to get rid of these numbers down here. And I'll show you how it works. If I multiply the top and the bottom over here by 3, that means that I would end up with 3 lots of x plus 6, that's multiplying the top, over 6. And if I multiplied both of these by 2, I would end up with 2x, 2 times x, over 6. Now we don't normally, when we're solving these, we don't normally actually show this full step here because it's really superfluous. If I know that the bottom numbers are the same and that both sides are equal, I know that the numerators must be equal. Okay? Because if that, like, look at it this way, if I had 3 sixths is equal to 2 sixths, that'd be false, wouldn't it? 3 sixths has to be equal to 3 sixths. So the sixes, the denominator, really don't matter. So when we set these out, we talk about cross-multiplication, and what we're doing is we are getting these things, and you can represent it this way. You can represent it as the 3 is being multiplied by that, and the 2 is being multiplied by that. So we get the same thing that I had on the numerator before, and it's assumed that they were over 6, okay? But we don't need that. We know that those two bits have to be equal. So I've got this. I now need to expand this first. I'll have 3 times x is 3x. 3 times 6 is 18, being equal to 2x. What do I need to do next? I need to get rid of the x's on one side. And I'll get rid of them from over here because it's going to be easier to take away 2x than it is to take away 3x. If I take away 3x, I'll end up with negatives. So I'll take away 2x here, take away 2x here, and I'm left with x plus 18 being equal to 0, okay? And if x plus 18 is 0, then x would have to be negative 18, because negative 18 plus 18 is 0, okay? Solved. Over this side here, you can see I don't have a denominator on the other side there. That's fine. I'm still going to do the same thing. You see any number around, and you can rewrite that number over 1 without changing the value of it. 4 is the same as 4 over 1, because 4 over 1 is 4, right? I hope that's not too confusing. Here, x plus 4 is the same as x plus 4 over 1, okay? So really what I'm doing here is I'm going to multiply that 3 over there, and I'm left with 2x plus 7 times 1 being equal to 3 lots of x plus 4. Now the bright among you could take a shortcut there and do that multiplication as part of that step, as an integral part of that step. I don't mind if you do that. I just don't want you to skip straight to the answer, but I want you to show some working out here. So I could have said, okay, well, that's going to be 3x plus 12, but I've just written it out like this as a precursor. 2x plus 7 equals 3x, that's that times that, plus 12. You can probably see that in this occasion, I'm going to take away the 2x again, and it's going to leave the remaining x on the other side. It doesn't really matter which side x is on, you can still work it out. So Let's see, what am I doing? Ah, yes, that's right. Getting rid of the x's. Take 2x, take 2x, and I'm left with 7 being equal to x plus 12. I need to get rid of that 12 that's being added there. I need to subtract 12 from both sides. 7 take 12, that's going into negative territory. Negative 5 equals x. Hope that's helpful. Bye.